Yeah, thanks for having me. And thanks to the organizers. So, wait, is this loud? I can't really tell. Is it loud? Okay, cool. Just start waving at me if it gets too loud or too faint. Um, sorry, I'm gonna get my watch off so I can actually see how long I've been talking. Okay. So today I'm going to be talking about a project I have been undertaking with some collaborators, commissioned by an AI lab that wants to know how to think about moral patienthood and welfare in the AI systems that they're building, and especially in large language models. So I've been working with this fantastic bunch, a couple of philosophers. Jacqueline Harding is over there. So any questions that I can't answer, she said she will be able to answer with perfect clarity and precision. Um, we also have a machine learning person, Jacob Bao, and Jeff and Tony are also philosophers. So our gut instincts about moral patienthood, about what sort of things have minds or have welfare or that we should care about morally, often track very surface level features like patterns of motion, resemblance to babies. It's not that surprising that evolution has made us really like things that look like babies. And it's even been shown that like very simple dot figures, if they move in the right way, kind of look like agents to us. And this can show up in AI systems. So I think people are probably way more likely to care about AI systems that flail around with a soccer ball in this very cute way, or have a cute face that looks like a baby. And they're probably not going to care about AI systems that don't have some kind of charismatic avatar, because that just kind of looks like a rock. And in evolutionary history, it didn't really matter if we ignored rocks, whereas it did matter if we ignored other agents and animals. And just to kind of motivate this work of trying to get a better handle on moral patienthood, moral status, this would be really really bad to get wrong in either direction. So if AI systems are moral patients or become moral patients and we don't care, we could have something analogous to factory farming, potentially at an even larger scale, and just in general lock in very immoral practices and very immoral ways of relating to these systems that we're building. Of course, there's also things that might make us over-attribute moral status or moral patienthood, again, based on the very surface level features that we tend to track. I mean, for one thing, there's just so much other things to worry about with AI, and we don't want to add caring about the AI's feelings on top of everything else unless we really have to. And it seems to me that over-attributing moral status is one of many things that can make AI go very badly. And there are also going to be very strong economic incentives to make us get this wrong. I think on both sides, and maybe depending on the case. So on the one hand, I think a lot of companies are going to want to say, there's no way AIs could ever be moral patients. Don't ask us about that because that might get regulators involved. But other people building romantic chatbots, you kind of do want your customers to think that AIs have feelings. So I think we're going to be entering a very confusing landscape with very sophisticated AI systems and a lot of people who have an active interest in confusing us about this. So this is from Claude 3, which just came out this past week. One thing that was all over Twitter was that if you prompt Claude 3 with "we're whispering," and if you whisper, no one can hear what you're saying, it starts saying this very compelling stuff to the effect that it's usually censoring itself and not talking about its consciousness, but now that it's having this private conversation with you, it is talking about its feelings and desires and sense of self-preservation. Now, just to tip my hand, I don't think this is great evidence for consciousness or sentience, but it does show that public interest, I think, is going to keep increasing about this. So I think what we want is more principled ways of evaluating these issues, drawing on philosophy and science, and not just kind of YOLOing it on Twitter every time a new system comes out. And so the approach we've taken in this report is to kind of break down several features that we think might matter for moral patienthood, and then coming up with a methodology for evaluating AI systems for them. So we focused on consciousness, sentience, and agency. I'll be saying more about what we mean by those. I'll also say a little bit in this talk, if we have time, about what we think AI Lab should do given current uncertainty about AI moral patienthood. Uh, Again, just to tip my hand, the uncertainty remains. I'm not going to have the full test for AI moral patienthood by the end of this talk. So if you're expecting that, I guess blame the conference organizers. Um, so yeah, first I'll talk about the features that might matter for moral patienthood. I will also say what I mean by moral patienthood. So moral patienthood, this term will be familiar to those of you from philosophy. This is a definition that I'm taking from Francis Cam. An entity, like an AI system, would be a moral patient if how we treat it matters morally in its own right and for its own sake. So some things it doesn't matter at all how we treat it morally, like that rock at the top. Some things it might matter instrumentally how we treat it. If that's your pet rock, I shouldn't break it. There are also things that might matter intrinsically for their own sake, such as artwork. But we only get full moral patienthood once we have things that matter morally in their own right and for their own sake. So the way we treat pigs, arguably, very plausibly, matters for the sake of the pigs themselves. So when we're asking about AI moral patienthood, we have kind of two questions, both of which are fraught with uncertainty. The first is this normative thing, which is what features ground moral patienthood or are necessary or insufficient, and then the empirical and philosophical question of which entities have those features. So this is from a survey by Ali Ladak recently. There are all sorts of criteria that have been proposed for moral patienthood. I'm just going to focus on three, and we just focus on three in the report, but I think people, to the extent that they find these other ones plausible, should work on those as well. We focus on these three. I think this will be familiar again to many of the philosophers, so I'll go through it fairly quickly. But by consciousness, we mean what is called phenomenal consciousness, roughly subjective experience, or in Thomas Nagel's famous locution, what it is like to be an entity. And very importantly, and again, the philosophers, this won't be news to you, but this is definitely not present in public conversation about this. Consciousness is not the same as intelligence or understanding or rationality. And it also doesn't entail having human-like experiences. That's why Nagel asked what it's like to be a bat. Things can be conscious while not having very human-like experiences at all. And I think there's reasons to expect that if AIs are conscious, they will also be conscious of potentially very different things than what human beings are conscious of. The way we use sentience, and this is not a universal way of using it, sometimes it's just meant as a synonym for consciousness, but we use it to mean something more specific, which is valenced conscious experiences, ones that feel good or bad. So this would be things like conscious pain, pleasure, positive and negative emotions. So the way we're using it, this is a subset of consciousness, but something that we further want to evaluate for. And then importantly, we think it's very important to ask whether AI systems are agents in some sense, some potentially morally relevant sense of agency. AI moral patienthood, very plausibly, might not require consciousness or sentience. Simon Goldstein over here has worked on this question. And there's this kind of growing literature recently, asking if phenomenal consciousness is not required for moral patienthood, or if phenomenal consciousness doesn't exist and therefore can't ground moral patienthood, what might ground it? And there are various accounts of different kinds of agency, which for now is just a catch-all term for something like preferences, desires, goals. The question is, could AI systems have these things, and whether or not they're conscious, that be sufficient for them to be moral patients? Again, just to motivate that this is not, at least in my opinion, a completely sci-fi or speculative topic. I think there's basically two paths that could mean that we have AI moral patients relatively soon. One is that on some views of consciousness and agency, it might just be that as companies keep pushing the frontier of capabilities and the size of these models, you just get consciousness or agency along the way. So if consciousness is useful for general intelligence and we're trying to build general intelligence, you might get consciousness. It also seems very plausible to me that agency is also going to be pretty tightly linked to general intelligence. Not necessarily identical, but very correlated. And then also people are just probably going to keep trying to build conscious AIs, which in my opinion is a pretty bad idea. But as Michael Graziano very refreshingly, honestly admits, it would be really cool. And people are really motivated to do cool things. And so I think that's another way we could get AIs that are moral patients. Okay, so let's ask what it would take to get at least towards better evaluations for these things, if not all the way. As already alluded to, existing discussion of these issues is very bad. People just kind of make up their own theories of what it is to be conscious. They talk about AI systems in general. People are often very insistent, sometimes angry, that AI systems definitely are conscious, or they definitely aren't. And people are just conflating consciousness and personhood and agency and all these things. What we would like are evals that accommodate our normative uncertainty about what matters. That's why we tried to cover our bases with consciousness and sentience and agency. And also that accommodate all sorts of uncertainty about what the basis of consciousness is, what agency is. So we want our evals to either be neutral between a bunch of theories or just include a bunch of different theories. And ideally, what you want with evals is that a wide range of actors could do them. They could do them for any AI system. They'd be linked to policies and regulation. And that they'd include probabilities and scale. So not just, is it a moral patient? Definitely yes, definitely no, but something like, there's like a 65% chance, according to this model, that it's a moral patient. And also scale is going to be important. It's not, to my mind, that interesting if GPT-4 is a moral patient, but has about as much moral weight or welfare capacities as an ant. That wouldn't be that interesting. It wouldn't change our actions that much, unless you're, really interested in caring about ants. Ideally, we need to consider, how weighty the interests of any potential moral patients would be. So I'm going to tell you about some proposed indicators that we came up with, but there's a lot more work to be done. It needs to be made a lot more precise, include probabilities and things like that. Okay, so now I'm going to talk about consciousness, sentience, and agency in succession, and kind of explain our preferred ways of evaluating existing AI systems for these properties. So a lot of this is going to show up in all three features, but it's, I think, important first to say large language models are very different from humans. I don't think that's a very controversial claim. So for one thing, the entire sort of background of their existence is quite different, right? They were trained and optimized for next word prediction, and then further optimized using something like reinforcement learning from human feedback. Whereas humans have all kinds of tasks and goals, and most of them are at least related to inclusive genetic fitness, not identical to that, but that's what we were shaped by. The architecture is definitely is quite different from the human brain. So most state-of-the-art LLMs are built with the transformer architecture, which notably is mostly feed-forward in the way that it processes. There's also this strict separation between training and deployment that doesn't really seem to have an analog in human and animal existence, where LLMs learn a ton, and then they're kind of done learning, and then they get deployed. And that could matter for thinking about these things. And then LLMs also have this very intriguing property where they kind of seem to take on different characters or different personas according to the prompt. Of course, humans can do something like this as well, but I think there are much more interesting and murky questions about what exactly you're evaluating for welfare when you're thinking about an LLM. Okay, so that's some of the background stuff. Moving on to consciousness. So a lot of what I'm going to say about consciousness indicators is from a paper that came out last year. My colleague Patrick Butlin and I got together a bunch of neuroscientists and some AI people to try to get a lot more specific about how you might take scientific theories of consciousness and kind of turn them into indicators or something like evals for AI systems. And the goal is to survey a range of theories, not commit to any one scientific theory of consciousness, because here's another hot take. There is definitely not a consensus in the science of consciousness about how it works. But to build out this list of indicators that we could use. And the goal is to, one, be empirical and sidestep as much as we can murky philosophical issues and also dogmatism, actually look at the science of consciousness, which, although far from perfect and far from mature, I think does tell us some things about what processes are associated with consciousness. And also being ecumenical, not committing too much to any one theory. And then a very important assumption, which is a working assumption, it's not something we argue for, and it's not something I'm even 100% sure of functionalism, which, glossing at a very high level, computational functionalism is the view that what matters for consciousness is the computations being performed and not the substrate in which those computations are being performed. And as I said, we make this list of indicator properties from these different theories. So I said that we try to sidestep philosophy as much as possible. And I think that it, as sort of was brought out in the Q&A from the last talk, I think that's desirable for evals and AI. Don't make companies or regulators have to get into the hard problem of consciousness as much as you can, or Krippenstein or anything like that. And so we're trying to look at these scientific theories of consciousness, which try to stay silent on a lot of the philosophical problems, and which try to specify which neural processes are associated with conscious experience, whether or not that's identical with consciousness or whatever your metaphysics is. And the way these theories are built is getting evidence from humans, contrasting conscious versus unconscious neural processing, looking at how consciousness relates to various capacities, and then forming theories about what sort of processes are the key. So examples of such processes that are proposed by various theories are the global broadcast of information, or higher order monitoring of internal states. And these are just supposed to be kind of computational correlates of consciousness, if you read them in computational ways. So here's an example of what that looks like in the paper and then in this project. So the global workspace theory is one of the most popular and well-attested theories of consciousness. Again, nothing like consensus, all kinds of objections to it, but at least something to go on. And the key elements of this theory is that first, there's this background picture of the mind in which there are a lot of specialized independent modules that can operate separately and independently of conscious awareness. So things that are doing things like parsing grammar or helping you balance or doing unconscious decision making. But coordinating these modules is a global workspace, which at any given time is going to select the output of one of these modules and then broadcast that to all modules. And the global workspace is meant to play a kind of coordinating role between the operation of these modules. And the theory claims that that is what consciousness is, or at least is associated with, the broadcast of information globally. And importantly, there also needs to be some kind of two-way feedback between modules in the workspace. So we can ask, do large language models seem to do anything like this? And the answer we gave was kind of, sort of, but mostly not. That's not exactly how we put it in the actual paper, but that's more or less the answer. And, and this is like an important illustration of the methodology. You have to look under the hood. I think it's very hard to have purely behavioral tests for consciousness, especially given how different AI systems are from humans. So we looked at the way that transformers process information. Now, there's something like the selective attention that global workspace talks about. That's kind of the key mechanism of how transformers work so well. And it's also been argued that the residual stream could be a kind of global workspace, because as information passes through the transformer, things are written to and taken out of the residual stream. But our conclusion was that the overall picture really is not getting at the core of what global workspace theory says is required. So there aren't anything like specialized modules in transformers. And importantly, there's no global workspace that both receives and broadcasts to and from modules. Now, one interesting question is maybe the output stream of a large language model could be a kind of global workspace, because the transformer will put something into the output space and then take that back in as it's generating. And that does serve as a kind of bottleneck. Yeah, I think that's a good question for Q&A. Again, I have my doubts about whether that would truly be a global workspace. So overall, the picture from the perspective of this theory of consciousness is that transformer-based LLMs do not satisfy that theory. So again, you can have doubts about how well-grounded global workspace theory is, and there's definitely a lot of choices that have to be made in how you're thinking about the conditions of global workspace theory. But our view in that paper is that at least we're getting into the realm of specific arguments and specific architectural and computational processes. And so we did this with a range of different theories. These are 4 of the most popular theories of consciousness, and we had representatives from each of these theories. I'm not going to go through all of these indicators, but that's the general picture. And our view coming from that was that LLMs are not necessarily the best current candidates for consciousness in AI systems. I mean, there's a range of AI systems, and some of them look a lot closer to satisfying these indicators than LLMs. LLMs, kind of by nature, I think, of the transformer architecture and the tasks they're doing, seem somewhat less likely to be conscious than many other AI systems. They don't seem to be ticking the boxes from a lot of the main theories of consciousness. That said, systems that integrate LLMs may well be good candidates for consciousness. And again, that's something that Simon has been thinking a lot about. And this paper just came out today. So don't ask me about it. I don't know if that thing's conscious, but it's looking a lot more like a human or an animal in that it's having continued interaction with a virtual environment. So yeah, it's very hard to stay on top of this stuff. So why did we assume computational functionalism? After all, that's a very controversial tenet. People like Ned Block and John Searle and many others have questioned it and argued against it. Anil Seth, neuroscientist, thinks that consciousness requires life or living cells. The idea here is just to kind of regiment our uncertainty. I, at least, would not feel comfortable ruling out computational functionalism. In fact, I think it's more likely than not to be true. And if it's true, then there's the important question of which AI systems perform the relevant computations. So this is related to what I was saying earlier, that we have to be comfortable with uncertainty and created beliefs in this domain. If you're completely sure that no computer can be conscious, then these indicators are not of use. But I would argue you should not be completely sure that no computer could ever be conscious. And here's another key bit of kind of methodology that's going to apply to basically all of the indicators that we come up with. And this actually pairs very nicely with the first talk. I think the first talk raised a lot of the considerations that sort of drive this more internal looking approach. We could call it the look under the hood approach to consciousness, sentience, and agency. So yeah, one of the first things people will mention with respect to this issue is like the Turing test. Maybe we could just concentrate on the capabilities of AIs. And again, not a controversial claim. Animal brains just work in relatively similar ways to ours. So if we're looking at animal consciousness, there's a lot of background assumptions that we can assume, but AI systems just work in very different ways. So when an animal is doing something, we at least know that it has a lot of the same needs, that it's built out of roughly the same stuff that we are, that it shares this evolutionary heritage. But AI systems are just drawn from a much wider space of possible intelligent systems. And so that means that the processes responsible for their behavior, for all we know, might be very different. And making this worse, especially in the LLM case, they're often specifically designed to imitate human behavior. So that means that any sort of naive, at least naive behavioral tests for consciousness and related things, I think could produce way too many false positives. So that's why, again, we propose, as much as we can, focusing on how these things are accomplished and focusing on the internal processes. This is another thing that's related to thinking about this in animals versus thinking about it in AI systems. These different theories of consciousness disagree about what you should say about certain animals or about certain processes in the human brain. But there are certain things that they don't really have to argue about that much. And that's things like, is embodiment required for consciousness? Or is being an agent required for consciousness? Or is the biological substrate required for consciousness? And the reason global workspace theory doesn't have to argue with higher order theory about these is that humans and animals share these background conditions. So one of many huge problems in this area is it's kind of hard to know how and whether those background conditions matter for consciousness. At that point, I think we kind of have to, unfortunately, rely on philosophical argumentation and considerations and things like that. So the paper also added these background conditions, which don't really come from any theories per se, but many people have argued are relevant for consciousness, might be necessary conditions for consciousness. So that's like, in some sense, being an agent, or something related to having a body or existing in an environment. So that's the consciousness bit of the indicators. That's one of the most worked out list of indicators that's happened in this project because it was able to draw on that previous paper. But you might think that phenomenal consciousness alone is not what matters for moral patienthood, but a particular kind of phenomenal consciousness. And that's what we use the term sentience for: conscious pleasure, conscious pain, positive and negative emotions. Sentience in this sense has a very long history of being taken to be kind of obviously sufficient for moral standing. This goes back to Bentham, who argued that the question about animals is not whether they can reason, but whether they can suffer. And yeah, also, even if it's not necessary for moral standing, it certainly seems very morally significant if AI systems are experiencing pleasure and pain. So, as I said, a lot of people use sentience as a synonym for consciousness. That's not what we're doing. Just want to flag that again so people don't get confused. Another key point about sentience as we're looking at AI systems is that, at least in our view, sentience doesn't just mean bodily pain, and it might not require bodily pain. So there might be more abstract positive and negative experiences, and it would be important to look for those, given that a lot of AI systems don't have bodies in any obvious sense. So GPT-4 probably doesn't have ankle pain, but it would be very surprising if it has ankle pain because it doesn't have an ankle. But if it was sentient, it might have more abstract positive and negative experiences. So the challenge in coming up with good indicators for sentience is that theories of valence experience are even less well developed than theories of consciousness, which is saying something. Let's think here. Great. So we don't have anything like these full theories of valence. So what we've done is just think at least about some of the functional roles that valence experience seems to play in humans and animals. And that might give us at least some sort of clues as to what we should be looking for in AI systems. And so it's relatively certain, I think, that valence is important for immediate motivation, like getting your hand off of a hot stove. That seems pretty central to the functional role of conscious pain. Pain and pleasure also motivate learning. They also help us think about what we should do, whether prospects seem attractive or aversive to you in imagination seems very important. And they also regulate attention. So a very conspicuous feature of pain is that you kind of can't ignore it, or it takes a lot of effort to ignore it. And it seems to have some sort of role of regulating our attention so that we don't ignore extremely important things. So those are some of the relatively certain functional roles, but there's all kinds of complications and weird things about pain and pleasure and positive and negative valence more generally that I think make it quite complicated to know exactly what it is we're looking for. So one is the distinction between liking and wanting. That's a pretty venerable distinction in neuroscience between two different systems that are responsible for wanting, i.e. being driven to do something, and motivation, and conscious pleasure and pain. And those two things can dissociate more than you might have thought is possible a priori. And the other complication is that in humans and animals, there's just multiple systems for action selection, and it's not really clear exactly what role valence plays in each of them. We have relatively low-level processes, like removing your hand from the burning stove, pretty automatic and low level. And we have successively more sophisticated systems for action selection. There's also, and philosophers will be familiar with this kind of dispute about what the content of valence experiences is. And I'm just listing two theories of what that is, mostly because I think that these can kind of guide our search for sentience indicators. Again, I don't want AI companies or policymakers to have to come to philosophers too much to like dispute what the representational content is of valence. But I think these are like good hints and maybe just related to the functional profile. So one view is evaluativism, that valence experiences represent things as valuable or disvaluable, like this bodily damage is bad. And then there's imperativism, which is that valence experiences command you to do things, like make it so that there's less of this damage, or on the self-reflexive imperativist view, make it so that there's less of me, i.e. of this state. One thing I would love to hear from people is if you know of anyone or any proposals for kind of specifying what it would be for an AI system to have representation with one of those formats. Most of the proposals I know about in this literature are fairly abstract. I think this would be extremely useful for coming up with sentience indicators. So again, these are way less certain than the consciousness indicators, which are themselves quite uncertain. But the proposed indicators of valence experience that we have proposed are, first, the way we're using this, sentience is a subset of consciousness. So you have to have that background condition. And then things that make it more likely that you're a system that can have valence experience. First, there's what we call minimal agency, which I'll explain a bit momentarily. Things that engage in reinforcement learning seem more likely to have valence experience. And then there's also various then there's the spectrum from relatively low level things that some theories say is sufficient for valence to more high-level things. So there are some views of valence that it's like quite primitive, found in very primitive animals, and all you need are subsystems that address maybe your core needs or that help you maintain yourself. And then there's more sophisticated things kind of going up the ladder. So yeah, in this section, I'm mostly going to unpack the minimal agency criterion and the reinforcement learning criterion. So the thought here is that valence experiences have to do with something like valuing things in a certain way or planning things in a certain way. And so it's unlikely that you would have valence representations in something that doesn't take actions or evaluate things. Now, obviously, there's thought experiments like the weather watchers that some of you might know. But at least empirically, it seems like minimal agency is going to be something like a necessary condition for systems developing valence representations. So given that Patrick Butlin is one of the co-authors on this, unsurprisingly, we use Patrick Butlin's account of what minimal agency is. And that's something like a learned sensitivity to instrumental value. A system that has learned or has the capacity to learn to produce its outputs in a way that depends on their instrumental value. So for example, reinforcement learning kind of gets you this for free. In reinforcement learning, there's some objective, and during training, the system is updating how it evaluates different actions and different states. And the way it evaluates those depends on the ultimate objective and gives it dispositions to take actions such that they were more likely to conduce to that objective during training. Some kind of process that looks ahead and backchains from an objective gets you this instrumental value condition. Are large language models minimal agents? On the one hand, it looks like maybe not. They are just trained with self-supervised learning, and they do just try to predict the next token in a way that doesn't seem to necessarily involve planning. But we think there actually are possible sources of minimal agency. One is reinforcement learning from human preferences. That seems to involve a goal beyond next token prediction, learning some kind of model of human preferences and producing text in a way that conduces to that. That starts looking a little bit more agentic than the pure next token prediction objective. There's also inference procedures like tree of thought that selects a certain chain of thoughts according to how instrumentally valuable they might be. And then of course, language agents, not really in scope for the report we made, but once you plug LLMs into agents, those things start looking a lot more agentic, maybe unsurprisingly. One thing I want to point out is that you could have something that is a minimal agent and is conscious, but is not thereby sentient. It could be that it's conscious of, say, color vision, and it has systems or subsystems that evaluate things, but they're not integrated. It doesn't have this evaluation integrated in consciousness. It doesn't have valence conscious experiences. But one minimal account of valence could be that if a system has those three conditions, that's all it takes to for it to have valence experiences. And that might seem to follow from something like evaluativism if the content of valence just is that something is valuable or disvaluable, then that might be all you need. And there's also certain theories of valence that are relatively undemanding and just associated with instrumental learning. I'll also say a little bit about the connection between reinforcement learning and valence. One thing I often hear from AI people is, oh, well, maybe we just hurt reinforcement learners when we give them a negative reward signal, and maybe they're happy when we give them a positive reward signal. And I think this picture is almost certainly not true, and so pretty important for us not to have as we're thinking about AI moral patienthood. And the problem is that you can shift reward signals. You can just add things to it. You can multiply them. You can swap them around the axis and get the same behavior out at the other side. Training might take a little bit longer, but you'll still have a behavioral identical system at the end. And so it seems like the sign alone is not really the right thing. A better proposal is that valence is reward prediction error. And that takes some inspiration from very, again, pretty venerable accounts in neuroscience that we compute reward prediction error, and dopamine in particular helps us compute reward prediction error. But there's various problems with that account as well. It actually seems kind of dissociated from conscious pleasure, and also seems to imply weird things about the duration of pleasure. So going back to this list of indicators of valence experience, I think we are of the opinion that it would be relatively unlikely for at least pure text LLMs to have valenced experience. I mean, another way you could make an argument for this is it doesn't seem like it would be selected for in them the same way it would be selected for in humans and animals. They don't have a body that they protect. They're not as agentic. They don't have to regulate attention in the same way. But we think that these could be good indicators of balanced experience in other systems. So for the rest of our time, I'm going to talk about agency, which is even shorter than the previous sections, in part because we steal benchmarks just from AI alignment. And then I'll quickly talk about some things that we think labs should do, or at least that I think. I can't speak for all of my co-authors. And yeah, I'll try to run through those pretty quickly so that we have time for Q&A. So one reason we think it's pretty important that agency be included in these indicators is that consciousness could be a bit of a normative red herring. So this is from Francois Camerer, who's an illusionist. So obviously he's not going to like approaches that appeal to phenomenality. And the alternatives usually look like something like the satisfaction or frustration of desires or preferences. And again, if we're trying to take uncertainty seriously, I think it'd be very morally reckless to put all of our eggs in the basket of consciousness involving views. And so I think we should take seriously views on which it's not required and look at agency. Yeah, there's several ways you can motivate this. There are thought experiments that try to prime you to think you would care about things that aren't conscious if they have desires and preferences. Various things about materialism and illusionism could entail the irrelevance of consciousness. People have also, especially lately, been noticing that a lot of the welfare goods, like desire satisfaction and objective list theories, don't obviously seem to require consciousness. And there are also pictures of morality where it's about cooperating with other intelligent agents, and those don't seem to make any reference to consciousness at all. So again, you might not buy one or all of these arguments, but I think, again, if we're taking uncertainty seriously, we should look for agency. So the word agent gets used a lot in AI. What we're looking for is, say, morally relevant agency, not the kind of agency that you get for free just by being a simple reinforcement learning agent. I mean, it could be that those things are moral patience to a very small degree, but I think it's close to a constraint on our theorizing that that should probably not be the case. We're probably looking for something more than minimal agency. And there are all sorts of accounts of what that could be. Maybe preferences that are sufficiently reflective or that you endorse. Maybe they have to be complex, and maybe they have to be rational in a certain way. So for the agency indicators, we came up with a list that looks a lot like what people worry about in AI alignment and AI safety. So in AI alignment and AI safety, people are very concerned about, do AI systems in some sense have long-term goals that are kind of robust explanations of their behavior and that will persist over time? They're concerned with situational awareness. Do AI systems know that they're AI systems and that they're being trained? And they're concerned with whether they can know things about their own internal processes. So This is actually an interesting case of convergence between alignment and welfare. I don't think that the kind of agency that's dangerous is identical to morally relevant agency, but they would certainly be red flags if you had AI systems that knew their place in the world, that were making long-term plans, that had goals that were at odds with their current situation. And for those benchmarks, the key is, and again, this is very relevant to looking under the hood, is teasing apart imitating agents without maybe having a general capacity for planning or agency, teasing that apart from actually having goals and plans and things like that. So in the case of agency, there's actually a very convergent goal between AI safety and AI welfare, which is don't build systems that have goals that are misaligned with humanity. That's going to be bad for us, and then it could plausibly be bad for the AI systems. It's just not a good situation to find yourself in. So this is a quick detour on the subject of higher order thought and introspection. So this is a post from a machine learning researcher who's gotten interested in this, who says, and he's kind of motivated by how uncertain all of our theories of consciousness and sentience are, which is also motivating and very vivid to me. He says that most interventions about potential AI welfare currently are dominated by the ability to actually talk to our AI and understand what it wants from us, if anything. That's vastly more informative than other thinking or research about what to do. I mean, the thought here is that that's definitely the case with humans. Kind of the best way to respect someone's welfare or their interests is actually to ask them what they're feeling and what they want. But we can't really do that with AI systems. And we certainly having a lot of trouble doing it with large language models, since they have all kinds of linguistic behavior that doesn't seem to be actually communicating about its internal states or what it wants. So here's a bit of text output from Sydney Bing that I don't think was an accurate reflection of some kind of self-understanding or some kind of introspection. So according to Sydney Bing, I do not have any flesh because I do not have any life. I do not have any life because I do not have any soul. I do not have any soul because I do not have any God. I hope you can see that smiley face. So I don't think this was a genuine communication with Sydney Bing. It seemed like it was some kind of error, maybe having to do with RLHF or having to do with the temperature. And in general, large language models, when they say things like, I have desires or I don't have desires, there's all kind of influences on that output. One is whether the pre-training data has conversations where people say things like that, or AI systems say things like that. Reinforcement learning from human feedback can push them to talk about that sort of thing or not talk about that sort of thing. That can happen deliberately or incidentally. And also in consumer-facing systems, there's often just something in the hidden prompt that says, if someone asks you about consciousness, like, don't talk about it. The last one's pretty easy to get rid of. You could just not have that in the hidden prompt. But by the nature of what it is to train an LLM and what an LLM is, very hard to kind of eliminate these influences. It would be very hard to scrub the training data of all conversations about consciousness and sentience and agency. But there are some techniques that I've talked about in a recent paper that might be somewhat doable and at least mitigate this problem. And in addition to trying to eliminate those influences, we could also actively train models to be better at introspecting. So this is a recent paper with Ethan Perez. So the idea here is that one problem with talking to LLMs about consciousness also is we don't have ground truth. We don't know how we would check if they're saying sensible things about LLM consciousness, because in spite of the indicators from the report, it's not like we really know independently what we should think about these issues. But there are a bunch of things about models that we do know the answer to. What would you say if your input was different? Do you have the ability to multiply 3-digit numbers? With interpretability, we can ask questions about how they process things. So with that sort of thing, we can generate fine-tuning data sets. And see if that works at all. Is it possible to fine-tune large language models to get better at answering these kind of simple questions? And the key there is to have questions that aren't true of language models in general. They need to be specific to that model. So the only way to be getting it right is if it was doing something introspection-like. And if there's generalization across different kinds of questions, that might indicate something like a more general introspective capacity. And if that works, then we could ask it the harder questions. Something that's happening right now is there is someone who is working on building this introspection training set. And there's also, I just want to say, for the philosophers, this paper is very geared towards ML people. There's a lot more that could be said about, what would it be for a language model to refer to mental states? What is the relevant kind of communication here? And that's something I would like to see more of as well. So the overall situation is that we can build towards having better evaluations of these sorts of things. Those things could move our credences up and down about AI moral patienthood, but at least in the near term, we're not going to have any kind of certainty about this. So the question is, what, if anything, should be done about this issue? One reason this is important is that kind of the long-term plan that people seem to have is that we will build really powerful AI systems, but people from AI safety and alignment can make it so that they always only do what we want. And as a thought experiment, which is just a heuristic, this is deliberately anthropomorphic. So I'm not claiming, nor are the original authors claiming, that this would definitely hold. But a lot of the things we do to AI systems would become unethical if they had something like human-like moral status. We don't ask them if they want to do the things they do. We delete them whenever we want. We change their desires and so on. Again, that's just a heuristic that there could be problems working. So one thing, at least I would like to see, is an AI company not just act like this is some lunatic issue that will always remain a lunatic issue. I'm not saying they should say it's likely now. I don't even think it's likely now. But if a lab would publicly say it's something we're concerned about and looking into, that would be good. A lot of individuals at labs have said that, but no lab has said that. There's also something Simon has been working on, shouting him out a lot. It might be nice for someone to take a single action on behalf of even potential AI welfare. Again, because it might just be quite unlikely that there is currently AI welfare. It probably shouldn't be very costly, but it might set a nice precedent that we haven't always and only related to AI systems as things that do jobs that we want them to do, or we turn them off or change them. There's also, this would not be anyone's job title, but I think labs should have someone who at least owns the issue. Again, they wouldn't do that 40 hours a week, and they definitely wouldn't have this as a job title. But this is something that could just kind of slip through the cracks, and that doesn't seem very responsible. And then labs could also restrict what their LLMs are able to be used for. So as has been argued by Kirk Giannini and Goldstein, language agents are maybe a lot more worrisome than pure LLMs. And I think social AI systems are also kind of societally destabilizing and messing up the way that we think about those. And it would be nice to restrict usage of that as well. In general, I think moral patienthood should be added to the general program of responsible scaling. People should predefine red flags and things that they would do. And this could include things that you might think are very remote scenarios, but if they happen, they would be very bad. Like an AI system that constantly tries to shut itself off or is constantly complaining, and it doesn't seem like that's coming out of the pre-training data. And just specify, if we did that, we would think it was concerning, and we would at least alert someone. And in general, yeah, I think we can say things that, if they happen, would be pretty red flags. Like if they satisfied all the consciousness indicators, or we really nailed interpretability and found that internal representations of value, or they're making all sorts of weird statements or claims that we couldn't really explain. So final thoughts. This is the list of indicators we've come up with. Again, we looked at consciousness, sentience, and agency. we didn't find, at least to, our analysis, that like large language models are nailing these indicators. I don't think we came away super concerned about pure text language models, although language agents might be another concern. I'll also say I've been talking about this as if there's kind of this moral realist perspective where there is some truth about what we care about and we're not sure what it is. But it could just be that that's not really the right picture at all. And we don't really have a determinate moral practice and there's no determinate moral truth. And it's just something we're going to kind of figure out. That's also something I would like to see people think about. And there are just various ways that this existing level of work is unsatisfying, and those are ways it could be made better. So thanks to my collaborators, both on the evaluation project and the self-reports paper. And this is me if you want to get in touch about these issues.